So this is just going to be a demo. There are no pretentious slides quoting philosophers. I was tempted to do that, but last summer, ROLI asked me to find a way to integrate Macs and blocks, and never done this kind of thing with hardware that didn't complete. It was in prototype stage, and I wasn't sure what to do. So one thing is, so Macs is kind of modular software, and blocks is modular hardware. So if you combine modular hardware and modular software, you get a combinatoric explosion. And then the other thing is, like, some of you may have just seen Jules talk, and you saw those comments in the API. So when I saw the API, there were no comments. And I had really no way into it, and so what happens to me if I don't have a way into other people's code is that I think that I get paranoid, and I think that they wrote it like contrary to everything I need. So then I found that there was this really low-level sysx part of it, which you didn't see if you were here for the previous talk. And I was like, oh, I know MIDI sysx. I'll just send MIDI sysx to this thing. So I wrote this whole thing, and then JB sent me a firmware update. And I was really excited because it's like, oh yeah, there's all these improvements in the firmware. So I'm gonna, everything's gonna work faster, or whatever. So I download the firmware into the thing, and nothing works. And then I start saying, hey, maybe I should update the API source code. So I go get the new API, and all the sysx messages that I had been sending to the blocks were gone from the API. And I had this sort of sick feeling in my stomach, like, okay, I just wrote this thing, it's never going to work again. But as JB said, I got some support, and Jules and I had a meeting, and we negotiated our differences, and basically I lost. And if you heard his talk, you know why. That basically, that was naive to think that you could send basically MIDI sysx messages to turn LEDs on and off. So let's go back to, so now that I had to, what did I do that was broken? So we have this other program we've had for a few years called Mira. And the idea of that is that you can take the user interface of that you make in Macs, and then you put it inside this magic object called a Mira frame, and it goes onto an iPad. And so everything you do on the iPad gets mirrored onto the screen of the computer, and everything you do on the screen on the computer goes onto the iPad. And I was like, okay, so we could make Mira for blocks. That was like the first idea I had. And it's really useful, like if you're ever trying to solve a problem, it's like, come up with X for Y, like Uber for returning library books, or something like that. And so let's just sort of look at a little bit of that first. So I have this, and my mouse just died, okay. So here's the, here's a bunch of objects that look suspiciously like things that might have to do with blocks. So up in the upper left-hand corner, there's this object that says not connected to any blocks. That's not a good sign. Let's see if I turn this on. Interesting. Maybe the whole demo won't work. Oh, here we go. Okay, so now it says it's connected to one LightPad block. So that object is called blocks.pad, and you can see, can you see the little blue triangle in the corner? So that indicates that it's actually happy. And unlike traditional Macs objects that deal with MIDI, where you have to connect them to MIDI in and MIDI out, the blocks notion of MIDI, like you can't do anything with it. It's like this constant stream of pings and acknowledgements and resending packets and like, so basically it happens behind your back. So there's actually an invisible max patcher that no one can see where all the MIDI is going in and out. And then it goes to this blocks system behind everyone's back. So all this connection stuff is done automatically. And unlike every other thing in Max, if I now disconnect the USB cable, you'll see eventually the blue light will turn off. Please, come on. There it goes. And if I connect it back, it will actually find it again at some point here. Come on. Come on. Well, so, yeah, why is it not finding it? Well, it used to work. All right, I'm going to quit and start again. But okay, note to self, don't do the disconnect USB cable. Now the thing is really unhappy. Okay, so that probably means that this is not a production thing, so I have to turn it off and on again. And it should be fine. So. Right, so you can, in theory, like if it doesn't get unhappy, you can disconnect it and connect it, and it will find it. So, but this is not the fun part. The fun part is that if you switch Max into presentation mode, you can lay out a bunch of these same UI objects. So you see, we switched to the camera, that that red square corresponds to that red square that you see in the upper left-hand corner. And you can see that there's a yellow thing around that black area, and that is the first scene. And you can make currently up to 16 scenes, but it should be theoretically unlimited. And just put objects in them, and then you can just interact with them. So if I touch this, you can see that something happens, and if audio were on, I think it triggers a sound. That sample's been in Max for like 15 years. It's my son when he was 2. He's now 21. Then if I click on this mode button, which you heard about, that's right here on the side, then go back to the document camera. So that will switch the scene to the next one. And I think this is like a filter. Did I turn the audio off? No. It's just not very loud. Let's see. What? If you're on HDMI and you switched away from the okay, right, okay. So that's an awkward part of this demo, I guess. But anyway, you get the idea. And then I can go to the next thing, which is the on-off switch for the next scene. So I think I have to put both of these on. And now if I go to the next scene, and I switch over to that, this is actually me in front of my computer with a JIT matrix being projected onto the thing. And what I didn't do in this particular demo is you can actually get touch events out of this while it's playing, so then you could recolorize the matrix or something fun like that. And it's really quite magical to play with something that's changing like that under your finger. So I think that's, there's one other one here. So this is a weird drum machine, I think. So if I, it's not working, but anyway, you get the idea. Oh, switch on the thing, right. So sorry about that. So the slider actually controls like how many, what the loop length is, and it's the only drum machine that goes up to 5. So anyway, that's a few of the objects. Like this one with the orange is called blocks.grid. It sort of emulates the kind of stuff that you would be able to do with a grid program that you saw before. There's a slider, toggle, thing for the JIT matrix. There's a multi-touch thing that I'll show in a second that shows the different touches. And then there's, so this other thing that I added, it was kind of irresponsible. So when you go in and out of what they call API mode, there's this beautiful green wave that shows up. And so I was like, oh, what I need is like drawing to the screen. So I implemented a sort of canvas thing. So here's some JavaScript code, and that is actually sending max messages to my canvas object, because I like to write these things in JavaScript more than max message boxes. So basically, we're just making an arc here, whose radius is controlled by the touch of my, like how hard I hit it, and then it'll explode after I release the finger, and the amount of the explosion is how fast I lift my finger off the surface. So let's see if that works. So this is patching mode, and then if we switch to presentation mode, you can see that the rectangle is on the pad here, but you can actually watch the same thing just scaled in patching mode. So let's go back to the camera, and you can see what it looks like on the. So you get the idea. And then finally, as Jill said, there's this topology aspect where you can find out the connections between the blocks. So just as a quick, how that operates in Mac. So let me close this other one for a sec. Oh, actually, I'll just do it right here. So, oh, I knew I would be awkward at that. So there's this object in Max called dict.view, which can let you see a dictionary, which is a way that we pass sort of structured JavaScript-like data around. And so we represent, it's the middle outlet, isn't it? We represent the topology of the blocks in terms of this dictionary. And so here you can see the same kind of data that you saw in the C++ API, except that you can actually manipulate this in Max. And if I connect another thing, for lucky, now you see there are two things. And then if we disclose, here's the connections. And I have a little bit extra information here because I want to do some stuff with that. So I have a, if I can remember the name of this thing, I think it's called Topology Fun. So this could be used at the ROLI factory to, oh, it crashed. If it didn't crash. So this could be used at the ROLI factory to verify that the DNA connectors are working. If it works, let's see. Okay, so here's the, so you can see the dictionaries coming out. And then I wrote this JavaScript code that basically analyzes. So a first trick here is the function dictionary. So all dictionaries in Max are communicated with the word dictionary. So the function dictionary in JavaScript is responding to this dictionary message that's coming from the blocks object. And we do this trick where we say new dict and then JSON parse. And that turns it from a Max dictionary into a JavaScript object. So now we can say, okay, if there are blocks and there are connections, run this topology to detect function. So I want to find out like which of the connectors on the light pad are connected, and then for every connector that's connected, I'm going to draw a triangle pointing to the connector on the light pad. And that's what all this code does. So we use the canvas feature of the multi-touch object to draw a triangle, as you can see down here, which is going to be white, and then we fill the triangle. So let's see if this works. Come on. Okay, so now that this block has decided not to, there it goes. All right, so you can see it's pointing there. Now if I put this one here, you get two. See, so now this could be very useful at the factory to see that maybe these connectors aren't quite right. That one seems okay. That one seems okay. Now how about this side? No, I think this, there we go. I just push on it and it kind of, so. Right. Okay, so you get the idea. So maybe we'll use this guy instead. These guys like each other better. So then the last thing was, so this is sort of coding to deal with the topology, but the philosophy that I think about Max is we want to try to take coding and substitute designing, so that you have this feeling like you could do the same thing as you do by coding, but you feel like you're designing. So what is the sort of design equivalent of writing an analysis program of topology? And I decided it was learning, right? You put the system into some kind of learn mode, you connect the two blocks together, and then you take some action when that happens. So let's see if I can make this work. So turn this off. And I'll make a new blocks dot. Do I have, how much time do I have? 10 minutes, okay. Okay, sorry. Make another blocks dot add. Okay, so what I'm going to do here is I have 3 scenes. I'm going to, this is not going to be anything functional whatsoever. I'm just going to make a toggle here. So by the way, if it wasn't clear, like the layout changes as you move things around. So if I'm editing right here, like I'm actually so this is like kind of designing rather than coding, kind of. So what I'm going to do is I have okay, so now I can just click on the scene on the computer, which you can't see, I know. And then if I switch to scene 2, you see it has 2 things. I switch to scene 3, it has 3 kind of messy things here. Maybe there's actually more than 3, but whatever. So, so our goal here is that when we connect this to one side, we're going to get scene 1, and the other side will get scene 2, and the third side, scene 3. So this whole interface is really experimental. I just did it this morning. But the idea is that there's another triangle, like the blue one in the upper left-hand corner. If you click that, you put the system into learn mode, and then you connect a block, switch to a scene, and then that establishes the stimulus and response for that particular action. So the next time you do it, it will match the topology that it recognized from your training session. Look, I'm using fancy jargon. And should do the same thing again. So click on my Learn button here. Okay, so now it's in Learn mode. And I will connect this on this side. And then click on this scene, switch it over to scene 1, and then turn the Learn button off. Oops. Learn button's a little small. Okay. Now I'll click on the Learn button again, switch here, and then click on scene 2, turn it off, click on the Learn button again, switch to scene 3. I'm not sure that's really on there. Okay. And turn it off again. Okay, so now let's see if it actually works. So let's put this camera on. So what should happen is when I connect this, it should magically just have one box on the screen. Yeah, it works. And then if I move it over here, there should be 2 boxes and 3 boxes, or 4, right? So I now have a totally different idea how to do this, which basically I'm going to make a little representation of this, and you can, like, I don't know, but that's going to be really cool. And I think this is a really, it's starting to get into, I'm just starting to feel like I'm putting my head into the combinatorial the explosion of modular software and modular hardware. And you start to see things like this, where it's like you're kind of patching in hardware, and it's kind of influencing the patch in software. But there's like a whole space to explore here, which I'm pretty psyched about. So I'm going to leave it there. If you have any questions, if we have any more time, I'm happy to defend the work that you just saw, or attack you, or whatever.
Thank you.